Welcome to the Faster Podcast by FLO Cycling, the podcast where we talk about anything and everything that makes you faster on your bike. This is episode 22, and today we have Josh Poertner from Silca joining us on the show for part 2 of his interview. During part 1 of our interview with Josh in episode 21, we discussed Josh's experience from his time as the head design engineer at Zip, as well as his advice for choosing the right tires and tire pressure to help you go faster. In this episode, we'll discuss tubeless tires and Josh's advice for getting the ideal setup. Let's jump into tubeless. On the Silca website, you have a heading that says you have redefining tubeless. Tell us how Silca has done that.
So, we really see tubeless as the future. We work with and are close to all of the tire manufacturers, and we see where the research and development money is being spent. And I'll tell you, it's not in tubulars.
It surely is not.
and within some of the companies, I know some of the R&D directors that we work with. I mean, they quite truly have zero budget for clincher tire development, right?
Really?
So I think the future, the path is clear. It's one of the areas that I like to tell my team. We would be crazy to try to predict what's going to happen next year, but we actually have a pretty surprisingly clear picture of 10 years out.
Yeah.
And I think tubeless really will be the norm. I mean, we're just in the early days at the moment, and they can be frustrating. And there's, I think there's a lot of variables in the bead diameters, the rim diameters. There's fitment issues. But it's very similar to what it was in mountain biking 20 years ago. And I think now we all know how that ended up, and similar, you can trace it back to automobiles. We also how that ended up. So tubeless is the future. For me, a lot of it was the frustration of kind of being a relatively early adopter of a lot of these technologies. I really found tremendous frustration with the early tubeless, and a couple of the things that seemed certainly obvious to me, and where the Silca tubeless products came from, were, the thicker your rim tape is, the harder it is to mount the tire.
Yes.
And
very true.
So, our experience developing our rim tape was quite funny. We started down that path and realized quickly that there's 2 companies in the world that make this type of tape. And we talked to both of them, and one of them said, "Oh yeah, we make the yellow tape, and it's this part number." I go, "Well, what's like the best tape that you make?" Like, "Oh, it's this one. It's this other part number. We'll take that one." Right. So we started with a film that's just a higher tensile strength.
Yep.
It's just a more refined film. And then coming from my Zip background and understanding that, carbon rims, because they're molded in metal molds, those molds have a mold release applied. And so the reason it's hard to get the stickers to stick to them or your rim tape to stick down is that there is residual mold release in the epoxy that you almost can't get rid of without like a sandblast or a bead blast. Yep. And the beauty of silicone, which is what they use in most of those mold releases, is that it's a mold release for almost all types of adhesives, but it's actually a mold or a bond promoter for silicone-based adhesives. Yep. And so we were able to just take sort of the chemical background of what mold releases are made of, and basically dope the adhesive of the rim tape with those same elements so that they would promote bonding rather than reject bonding. And so, from an engineering side, really kind of simple. From a, business side, one of those things that seems simple and then somehow always takes a year to get done, because everybody you talk to, everybody along the way, looks at you and says, well, nobody's ever asked for that before. Why would we do that? Yeah. And so, yeah, you know how it works, yeah. Right? But so that was really our first step in there. Our rim tape's about half the thickness, between a third and half the thickness of the other tapes out there at a similar strength. And so it's a little bit lighter, but it really just buys you easier tire installation.
Nice. Right. Nice.
And then the other thing that had really just driven me nuts, the valve stem rattle of traditional valve extenders and looking at the problem of breaking aluminum tubeless valves, and really it started honestly with the little 2 half moons that get kind of wallowed into the epoxy on either side of the valve hole with your tubeless valve.
Yep.
From the and trying to think of a way to solve that, and had this realization of, if I make a little rubber grommet with a spherical negative and I make a valve nut that has a spherical positive, I can make I can turn that into a ball and socket and take the bending load out of the valve, right? Because that's why valves break. Yep. As you guys know, when you make the rim, it's actually pretty darn hard to get the ID and the OD hole in the rim for the valve exactly radially, like on the same radial axis as each other. And so every carbon rim I think I'd ever looked at that had the half crescent moon shape wallowed in next to the valve hole, it's much more pronounced on the one side. And, we've seen it bend valves, we've seen it break them. And so that was really how that project came about of, hey, let's make a valve stem and make it ball and socket so that there's no bending in it. And that should eliminate the valve breakage and the valve bending and the other issues that can come with that.
Nice.
And then halfway into that project went, well, I'm making this silicone piece, I might as well make it Aero. Might as well make it look like something. And so, of course, it developed into this whole kind of other, this whole other project.
Nice. Cool. So our next will be tubeless allows you to run lower pressures. What pressures do you typically recommend for tubeless versus a tube setup? So basically,
for road,
you can usually run lower pressures with a tubeless tire. How much lower are you seeing tubeless allow you to go with pressures? Like, let's say you get tubes, you're at 80, you go tubeless. How much difference are you seeing?
We've certainly seen in the data for a given tire, the optimal pressure really stays the same if you're using a latex tube.
Okay.
Butyl tubes they skew the rolling resistance data quite a bit. But if a 23 millimeter measured tire has a 85 psi optimal on a surface, I can't say that I can see differences enough to call them differences.
Okay.
In the data, I think in mountain bike, for sure, it's a huge difference, right? And in cyclocross, I think what we're seeing now, the challenge is really much more related to burping.
Yeah,
we've got some of our lightweight or lighter weight athletes at like Cyclocross Worlds this year. We're talking pressures in the 18.5, 19 psi range. I mean, it's kind of mind bending.
Wow,
how low some of these numbers have gotten, and that's probably the one place where tubulars really still have the edge, right, in cyclocross, because
it's so low.
It's just so low, right? And we really struggle to get, you can find that optimal pressure, run it in the tubular, match it in the tubeless, and probably do it at a little bit lower rolling resistance. And then, there's one or two spots in a lap where maybe the tire burps, and, now again, you're back to one of those very asymmetric penalties, right?
Yeah.
At 18 PSI, you burp a tire and you've got problems.
Yeah. What's your favorite sealant and why?
I don't have one, and I really look at the sealant market. We actually looked at getting into the sealant business at one point and realized that really it's almost all the same, with just a few slight variations. And the challenge with that product type is that everybody is just camping out on a spectrum, right? So if your stands, you're I think a very good balance of a sealant that lasts a long time and will fill a pretty good sized hole pretty quickly.
Okay.
And if you're orange seal, you come out and you kind of develop the product around filling bigger holes and maybe filling them a little bit faster, but because the things you had to do to get there, you now dry out a lot quicker, right? And so you really have to stake out a place on that spectrum, and say, no, we're going to do this, and here's why. And certainly from a engineering and business perspective, for me personally, that's just a very boring place to be. Right? We're 5% better than the other guy at this thing, and we're 5% less good than this other guy at this other thing. And
we're the middle ground. Not really on your grievances list. We're a continental sealant.
And I think like so many things, it's a little bit like brake pads, where the real proper answer is just that you should probably have 3 or 4 options and pick and choose them depending on what you're doing.
Right.
And of course, that is not what people want to hear.
Right. I want the best. Yeah. I want the best.
Yeah. I want the best at everything. Well, certain, brake pad compounding is another thing. Well, okay, you want the highest grip, highest friction, whatever. It's not going to work in the cold.
No.
Right? I want it to be the best in the cold. Well, it can't. It's the very nature of what you're asking. It can't do that.
Exactly.
And so I tend to try to avoid categories that are linear spectrums of choice.
Yep. Here's the big question. So you can save 3 to 4 watts by switching to latex from butyl. What are you seeing when you switch from latex to tubeless? Is the rolling resistance the same?
So tubeless has introduced a whole new challenge to rolling resistance, because it's every tire is unique, and its construction is now what's driving the rolling resistance. So no, it's not as easy as just the old days of saying, oh, you swap your butyl tube for a latex one, you'll save a couple of watts. I mean, there are tubeless tires. That the fastest tire really on Earth right now is made by Vittoria. It's their TLR Corsa Speed.
Yep.
That it's, I mean, when Renee sent me the early samples of that, we ran it and went, oh my goodness. I mean, it just, we reran it a couple times because we thought like the sensors are bad. I mean, there's some, the data, this is just bad data. This can't be possible. And then similarly, there's tires, not to name names, but there's tires where there's a tubeless version and a standard version, and the tubeless version might be 4, 5, 6 watts worse than the standard version. And so we don't have enough consistency in the space yet to really be able to make any sort of blanket statement.
Okay.
I
have
think
you tested the new 5000, the GP 5000?
I have not personally tested the 5000. I've got a data set on it from another party.
How does it look compared to the TLR Corsa?
It's not as good. It's not as good. Now, it's better than the 4000 was. So, I think the 4000 did a great job of staking out a space where they were durable and puncture resistant enough, and very good aerodynamically, and quite good in rolling. And the 5000, from what I've seen, the Aero is maybe a slight step backwards to sideways. And I think a lot of that comes from the fact that it's almost impossible to design a tire for Aero. I tried for years.
Tell that story.
And it's you can make 1 million prototypes and wind tunnel them and CFD them, and the reality is when you inflate, you got all this stuff stuck together, and when you inflate it, it just doesn't do what you want it to do. And I love the crew at Continental, because they've been very open from day one of like, hey, we have no idea why this thing is so fast.
I know.
Right?
I saw that story
I mean,
too.
It's very unintentional. It just worked out that way. Yeah. And I think, there are a lot of things you can do with tread thickness to improve Aero, but they have big rolling resistance penalties, right? And so, I think it took the 4000 so long to be replaced because they just had really stumbled into such a beautiful product, sweet spot of, just a beautiful product. So, the 5000, I think I haven't actually ridden it yet, but I think it's going to be, it's an improvement almost everywhere except for Aero.
Yeah.
I think it's a heck of a tire. The TLR is a phenomenal tire in CRR.
How does it do with aero and puncture resistance?
Not good for either one. So, I think for a lot of athletes, it's almost do your own testing. There's the rolling resistance is incredibly low because there's very little in there to generate friction or prevent punctures.
Right. Yeah.
It is a racing tire. And I think, as we know, that the challenge with that is, quite often taking that risk, it works out for you. And when it works out, that's awesome. But the times that it burns you, again, we're talking, right, very asymmetric effects.
There goes 5 to 10 minutes. Yeah. I
was a tenth of a second, faster when it worked, and I was 8 minutes slower when it didn't. Or for a lot of time trialing, it maybe you DNF'd, right? So these are discussions we have a lot with our Pro Tour teams, and it's quite funny. Actually, today we announced that we're coming on as a official technical partner with EF Education First, and we had been working with them as a sort of a consultant partner over the last few years, and they were buying a lot of tools and speed balance and latex tubes and things from us, and that was an interesting discussion. They ran TLRs at the Tour de France this year. And they ran them tubeless, and they ran them with, our valves and speed shields and kind of that whole package. And, we had some really interesting discussions there about the risks associated, right? Hey, it's a couple watts faster, but, it's, if it goes bad, it's going to be bad. And, I think for me, I tend to look at myself as I don't care what decision you take, but I just want you to be fully informed.
Yeah, right. So from, obviously tubeless has been well adapted for mountain and certain things like that. From a road and tri perspective, it's been much slower. Is that something that you recommend for road cyclists and triathletes? Is a tubeless setup?
If you're tech savvy and you like working with your equipment, and you don't mind spending the time with it, I think it's a fun experience personally.
Okay.
Honestly,
it's a very Josh Poertner answer.
Yeah. Well, so, I'll take myself, when I was racing and training, I worked on my bike obsessively, and I really enjoyed it. And I still, if I have the opportunity, I love wrenching on bikes. When I travel, I was just in Majorca at various team camps working with our teams, and I love if they'll let me touch the tools and work on the bikes. I love it.
This coming from the guy who makes the tools, they should let you touch them for sure. Yeah. Hey, I made that.
Well, as one of my favorite pro mechanics, Nick James, who's a head wheel builder at Zip, he's got this great poster that says something along the lines of old cranky mechanics or old cranky guys make far better mechanics than young pleasant guys or something. And so there's I kind of have my list of guys, my pro mechanics who will let me touch the tools, and those that won't.
That's funny.
And the reality, you don't want to get on the bad side of a mechanic. So but no, I enjoy it, and I think if I had the time in my life to do it, I would probably have all my stuff tubeless, and I would actually ride, which I kind of don't.
Yeah. Happens when you run business.
But the reality of, I've got 2 kids, and my wife has an amazing but insanely busy job, and we both travel a ton, and running this business. And if I ride a day a month, I'm lucky, and I in no way want that experience to be, my tubeless is dried up or my sealant's dried up, right? It just
from a
needs
speed perspective.
It just needs to work.
It does make sense, right? There's not many situations now where you wouldn't recommend tubeless from a racing perspective if you have the setup, because it is proving to be faster, especially as the new tire technology is developed, or as fast as latex.
Well, yeah, if it's the right tire. The right tire. No, I don't have data in front of me, but I would say that the fastest tire, that TLR, is probably the only tubeless tire in the top 10 right now of fast road tires. I mean, it's coming,
Yep.
but we're not there yet. Yeah, no, we're I would say,
Okay.
But 12 months from now, if you're listening to this podcast in 2020, what I just said is probably invalid.
Exactly. Okay, let's talk about the speed balance and the speed shield. Basically, so everyone balances their car tires, because if your car tire is not balanced, it's a horrible experience. What a lot of customers don't recognize is bicycle wheels are inherently unbalanced because of your valve and all of these other things. And typically nobody balances a bike tire. As a wheel manufacturer, you always get the call that the bike is bouncing in the stand, and it's just kind of a thing that happens, right? So you guys have developed a product that actually will help balance the wheel out. So tell us, one, why that matters, and two, is it faster?
Okay, so yeah, the quick history, and with me, nothing's ever quick, but the quick history is when we developed the 808, that 82 millimeter rim, the riders loved time trialing on it, and Fabian Cancellara decided to road race on it. And if you remember, he won that crazy tour stage, I think in 07 or 8, where he just kind of TT'd off the front for the last kilometer and a half. And at the time, that was a 420-ish gram carbon rim, and you're running a 250 gram silk tire made by FMB with a brass valve stem and a 80 millimeter valve extender on it, right? So the 18 or 20 grams of imbalance in a wheel system where your total perimeter weight is on the order of 650 grams or something, that's a lot, right? And at the speeds that the guys are going in the Pro Tour, they really feel it. And so from pretty much that moment on, I every year would go over for him, and ultimately it spread to a bunch of the other guys once they realized we were kind of dumb enough to go and do it. And we would, I would spend probably 3 or 4 days at each of the service courses balancing wheels for the tires the guys are riding. And I think, the challenge, as the manufacturers have, is I could balance the wheel, but I don't know what tire and valve stem or tire tube valve stem setup you're going to put on it. And so I really can't, without dictating to you what tube and tire to use, I can't make this decision for you, right? And so as the wheel manufacturer, we put a handful of grams of counterweight there and hope that that's good enough. But it really is depending on these other factors. You think of like the latex tubes, they're sleeved together at the valve, so all of your overlaps in the system are at the valve. The valve stem has a butyl flange that's used to bond it to the tube itself. Then the valve stem. Then if you use an extender, the extenders have overlap where they have to thread together. And so it's pretty common to have 10 to 15 grams of imbalance there. And, it's hard. It is very hard to quantify the losses there, because we're talking sub-watt, right? And anything in a cycling system that's sub-watt is very hard to find. Even in the wind tunnel, right? And so it's an effect that's probably on the order of hidden versus exposed spoke nipples in a good, well-shaped rim, right? Yeah. I mean, I remember when we were years ago at Texas A&M, you just couldn't see the difference. And then, when San Diego came on and we had this sort of 10 gram repeatability of the San Diego wind tunnel, you would see a difference of about 10 grams. But of course, with your marketing hat on, that's 10 grams. With your engineering hat on, you go, well, when my variance is equal to my uncertainty, I can't exactly say that that's, like a bona fide proven, advantage. But yeah, if you think of it from the imbalances perspective, the bottom of the wheel is at 0. The top of the wheel is going at 2 times the bike velocity. And so if you've got this 10 or 15 gram imbalance, you are accelerating that thing from 0 to, say, if you're going 30 miles an hour, that thing's going from 0 to 60 miles an hour forward and back to 0 in every rotation. Right. And so you have this very quantifiable acceleration, deceleration cycle in the rim. And some riders are, I would say, more perceptive to it. A lot of our track guys are actually just had a meeting yesterday with some riders who are going over for some 6-day racing in Berlin. And one of the guys we work with, Matt Giddings, is this amazing, he races in the paced Derny competitions. And so the average speed for these guys is like 54 miles an hour. I mean, it's insane. And yeah, if you've ever seen it, it's unreal, right? They're pacing a motorbike and they're racing each other. And you just watch it. You're like, my God, these guys are like, how are any of them alive? Right? Yeah. But you think at the 50 mile an hour range, that imbalance becomes a huge problem for them. Yeah. And then on top of that, they're on these, very smooth wooden tracks. And so there's no sort of external noise to hide the balance effects, right? I mean, they really feel it. And so, I would say today, probably the top 3 or 4 teams, they all balance the wheels. They all largely probably do what we did in the old days, which was a little bit of clear silicone, RTV silicone caulk in a spoke hole and a couple of ball bearings or something. I think pretty much every wheel manufacturer in the Pro Tour has a no speed shield or a no speed balance clause in their team contract, because the consumers still see that as a wheel problem. Okay. Right. And I think, if you're a Specialized or a Zip or whoever, you don't want it to seem like you have a problem that this Silca product fixes. But the reality is it's not a wheel problem.
Okay. No, right? it's yeah. Yeah. Okay. Last question before we get to our famous watt point question, and that is the speed shield. So you guys have developed a little Aero fitting that goes over your valve stem. Talk about that and how much time can it save you?
So Speed Shield, yeah, the little Aero guy, it covers about 10 millimeters of valve stem. It eliminates rattle. It seals out the moisture. Kind of looks cool, but it's one of the things that, before I left Zip, we were developing the wavy, radius wheel, what's now the NSW. And so we'd been working on that for, probably 18 months when I left, and had, even just seen with, if you took, clay, right? Wind tunnel clay, and you could, build these protrusions onto the rim, you could actually increase stall angles. And so I'd kind of had the idea in my head for a while when we started. And a speed shield on its own is probably on the order of 0.6 watts in the wind tunnel, right? Because you're covering 10 millimeters of a round thing, which is just a very bad shape. Again, 0.5, 0.6 watts in the tunnel is hard to really call conclusive, but if you match it with a speed balance, you will consistently see about a 10 to 12 gram savings in drag, which is right on that order. We're roughly in that like 9 grams per watt at 30 miles per hour sort of
okay, cool
regime. So yeah, right about a watt.
All right. So here's the last question that we ask every guest, and the idea, we call it the watt point question, and the idea is that if the listener follows the advice given by the expert on the show, how many watts is that worth? So we always base it on a rider with a 300 watt FTP. In this case, it may not be quite relevant to the FTP, but let's go with the optimizing tire pressure for both aerodynamics and rolling resistance. So in your experience, how many watts is the right tire pressure worth? Going from like a bad setup to the optimal setup.
From a truly, if I pick a really bad setup, it's probably in the 20s, close to 30. I have seen, we have seen 10 PSI ranges after the tire pressure breakpoint worth on the order of 20-ish watts on rough surfaces. And you certainly see that on cobbles.
Wow. With rolling resistance primarily.
With rolling resistance. Yeah. You think of, post breakpoint on cobbles. Yeah. You can you can see 20 watts over 10, 15 psi. And then aerodynamically in there, you're probably, I think the challenge is that the aero effects, from my experience, you tend to see at the high pressures.
Yep.
And then the huge deltas in savings for rolling resistance tend to be on rougher surfaces where you'd naturally be at lower pressures. So you couldn't exactly I can't save you, 8 aero watts at high pressure and 20 rolling resistance watts at lower at the same time. But and I think paying attention to it, you could probably consistently on a daily basis at your next event or race, you're probably consistently in the 12 to 15 watt savings range by paying attention to both of those. Yeah, it's real. It's very and again, I think it's one of the reasons the Boras and the Skies and the EFs of the world have brought us in, right? I think it's for me, that's been, I think, the most exciting part of this Silca journey is taking this stuff that really wasn't being thought about or talked about and sort of mainstreaming it.
And a general rule of thumb is lower is always better than higher because of that break point, right? So if you're going to shy one side, go a bit lower.
Absolutely. Yeah. There's a crazy kind of nonlinearity there that, 5 too low might be 0.6 or 0.8 or a watt, and 5 too high could be 4, 5, 6 watts.
Wow. And then when you say cobbles, is that similar to a gravel surface for gravel riders and mountain?
Yes. Yeah. And it, again, not all, how do we define gravel can be a challenge, but yeah, absolutely. I think of, one of the most punishing surfaces from this perspective that I've ever seen is the flint, the kind of embedded flint in that dirty Kanza soil.
Okay.
Right. In a way, it's you're not riding on sort of a loose packed, uneven surface. You're riding on a relatively hard packed, smooth surface where you have these fixed protrusions that you're kind of running in. You're impacting.
I live in San Diego and ride on parts of that course all the time, so I know exactly what you're talking about.
And that can be just amazing. The asymmetry in that data. I mean, I would say for a lot of surfaces that, our hockey stick graph, the sort of blade of the hockey stick out to the right, it's somewhat steeper, maybe twice as steep as the left side of the graph, right?
Okay.
But on some of these, and particularly on like the cobbles of Roubaix, some of the stuff we've seen on the Kanza course, I mean, the steepness on the right side of the curve is
crazy. It's
not quite vertical, but it's very steep. And you can easily be 10, 15 watts. I think that I've got a cool. I'll have to pull out. I've got a cool slide we did after Fabian's win at Roubaix in 2010, looking at the sort of the sum of all of the watt savings we were able to find in our testing. And the graph of his tire pressure to speed was amazing. I mean, it just, every time we lowered the pressure, he just went faster on the same watts. And it literally just is faster, double wheel broken.
That's crazy. Yeah. Wow. All right, man. Well, this has been an awesome episode. Very cool information, some great stories in there. Where can listeners learn more about you and Silca?
So you can find us at silca.cc. And then we are also, I'm launching as a new side project because I needed something else to do, my own podcast, which is the Marginal Gains Podcast,
awesome.
Which can be found at marginalgainspodcast.com. And really with an eye on kind of telling some of these stories and sharing some of the data, and similarly helping people get faster through science.
Man. Share the podcast love. Let's get some people to come over and listen to that podcast. Yeah, absolutely.
Exactly.
Cool, man. Well, again, it's always a pleasure talking. We've known each other for years now, and you're a great guy, great resource. You've helped us many times. So thank you for being on the show. We really appreciate it, and I think the listeners are going to love this episode. Awesome. Thanks.
Awesome.
Yeah, take care.
Thanks so much to both of you.
Yep.
Cheers.
Thank you for listening to this episode. Be sure to listen to episode 23, where we interviewed Tom Anhalt, one of the industry's smartest engineers, to discuss rolling resistance and aerodynamics. If you enjoyed the show, please help us by sharing our podcast and by leaving a rating or review. If you want to learn more about our company, FLO Cycling, please visit us online at flocycling.com. That's F as in Frank, LOCYCLING.com. You can also find us under FLO Cycling on Facebook and Instagram. Until next time, ride safe.